In this video, we're going to be looking at mutually exclusive events and independent events. Mutually exclusive events are events that cannot simultaneously occur in a single outcome. Therefore, the probability of both events happening is 0. For mutually exclusive events, the probability of A and B equals 0. Examples of mutually exclusive events include on a single roll of a die, rolling an odd number or rolling an even number. On the roll of one card, on the draw of one card and drawing a diamond and drawing a club. On the same exam, earning an A and earning a C, being in Connecticut and California at the same time. So these two things can't occur at the same time. They don't overlap if you think of a Venn diagram. Examples of non-mutually exclusive events: rolling an odd number and rolling a 3, because 3 is an odd number. Drawing a diamond and drawing a jack. Well, there are jacks that are diamonds. There's one. On the same exam, earning an A and a passing grade. Those also overlap. When rolling a die, getting doubles and a sum of 4. 2 and 2 is the sum of 4 and getting doubles. So mutually exclusive events are two events that will not overlap if you had a Venn diagram. If you look at non-mutually exclusive events, if this is event A and this is event B, you could say event A is this portion, and then event B is this portion. Okay, you can kind of see that overlap there for that orange. So the overlap area is what makes them non-mutually exclusive. And this part here is our intersection. Disjoint sensor sets that have no elements in common, so that's just another vocab word, disjoint. The intersection of A and B is a set of elements that belong to both A and B, and the symbol is the intersection symbol, and then this is the union symbol. Okay, so the union of A and B is a set of elements belonging to either A or B or both. All right, so today we're going to look at the addition rule for probability. This is the event of A or B. All rounding will be to 3 significant digits. If A and B are any two events, then the following holds. The probability of A or B, or again the union, is the probability of A plus the probability of B minus the intersection of A and B. This is what you use for non-mutually exclusive events when there is an overlap. So basically, you're taking out the intersection so you don't double count it. If A and B are mutually exclusive, then the following holds. The probability of A or B, again, the union is the probability of A plus the probability of B. And since there isn't an overlap, you don't need to take that out because you're not double counting it. All right, so the probability of, you select a card from a standard deck, find the probability that the card is a 4 or an ace. So we're looking at the probability of a 4 or the probability of an ace, and these are mutually exclusive. Okay, so they do not overlap. Okay, so these do not overlap, so we don't need to worry about that. Probability of a 4 is 4 out of 52. Probability of the ace is also 4 out of 52. So you would get 8 out of 52. And then if you were to round that, you're going to get 0.154. Okay, probability for number 2. You roll a die. Find the probability of rolling a number is less than 3 or rolling an odd number. So these do overlap. So probability of rolling a number that is less than 3. Less than 3 will not include 3, so that's going to be 1 and 2. An odd number is 1, 3, and 5. So another thing you can do is just look at your sample space, and there are 4 items in the sample space, 1, 2, 3, 4. So it's going to be 4 out of 6, which is 2/3, which is 0.667. So this is one where you could probably do using common sense. If you wanted to use the formula, the probability that the number is less than 3 is going to be 2 out of 6. And then probability of an odd number is going to be 3 out of 6 minus the overlap. So the overlap is going to be the 1, so that's going to be 1 out of 6, and there you get the 4 out of 6. So that's what they're doing with the formula for that. The next example is a two-way table. A blood bank catalogs the type of blood, including positive and negative Rh factor, given by donors during the last 5 days. The number of donors who gave each blood type is listed in the following table. A donor is selected at random. So it's a two-way table because one direction, here vertically, you're looking at the blood type, O, A, B, and AB type blood. And then the Rh factor is going horizontal, positive, and negative. So find the probability that the donor has type O or type B blood. So this is mutually exclusive, okay, because you won't overlap. So the probability of type O blood is 184 out of 409, plus the probability of type A blood is 164 out of 409. So remember, when you add, you keep the denominator, and we're going to get 340 out of 409, which will be 0.851. Number 4 says, let me show you that. Number 4 says, find the probability that the donor has type B blood or is Rh negative. So now there will be an overlap. So here is type B, and then here's the Rh negative. So if you look at the table, we don't want to double count the 8. So what they're going to do is we're going to do 45. And now that we know that we're adding and subtracting, I would just keep your denominator and then just put it all together kind of at once. I think it makes the math easier. So the probability of type B blood is 45. The probability of Rh negative, 45 out of 409, you're going to have 65 out of 409. And then you have to subtract the 8, otherwise you're double counting it. All right, so when you do that out, you're going to get 102 out of 409, which is 0.249. This was not mutually exclusive, so you had to subtract the overlap. Okay, number 5 and 6 are very similar. So for 5, find the probability that the donor has type B or type AB blood. Go ahead, try 5 and 6. You can pause it and then take a look at the answers. All right, so you're going to do 45 over 409 plus 16 over 409 to get 61 out of 409. That's because these are mutually exclusive. So there is no overlap to worry about, and your final answer here will be 0.149. And then the last one is not mutually exclusive. I'm going to lift this up a little bit. Is not mutually exclusive. So probability of type O blood is 184 out of the 409. Rh positive is the 344 out of the 409. But I just double counted O positive blood, so I have to subtract the 156, so I don't double count it. And I get 372 out of 409, which when you round, you get 9.910. All right, hope this helps. Thanks for watching.